Bismillahirrahmanirrahim. Guys, this is the new topic and valence shell electron pair repulsion. Actually, how mathematics is involved in chemistry. So this, by this theory, we can explain the angles in the given structures. Now, there is no direct relationship between the formula of a compound and the shape of its molecule. So shape जो है, it's the given, and this theory will define the structure. Okay, this theory will define the structure as per the shape of the as per the formula of the molecule. The shapes of these molecules can be predicted from their Lewis structures. So what is important, that you should know the Lewis structures, and only then we can predict the shape. However, with the model developed for this predicting the angles and the shapes is called valence shell electron pair repulsion, or VSEPR theory. Now, this is you need to understand that this theory is used to predict the shape of the molecules, and the key thing in this thing is the electron pairs that surround the central atoms of molecule. Now, this theory was first presented by Sidgwick and Paul in 1940. Now, this theory is actually based on the assumption that the molecule will take a shape as such, based on the electronic repulsion in the valence shell of that atom. So, ये जो आपकी valence जो मतलब molecules की जो shape है, वो actually depend होती है, totally dependent on electronic repulsion. अब ये electronic repulsion जो है, इसी की बेस के ऊपर shapes जो हैं वो predict की जाती हैं. Now, first of all, we must understand clearly that what is meant by the VSEPR theory. So, the abbreviation VSEPR theory is actually based on the on this thing that there is a repulsion between the pairs of valence electrons. Now, if you remember, let me get my pen. If you remember in the class, I told you in the class that, for example, if this is the nitrogen, okay, this is the nitrogen, and these are the two electrons of nitrogens, and one pair, three unpaired electrons. तो ये जो electron pair है, it's इसका जो impact है on these, ठीक है, ये it will define the shapes. So, the pairs of valence electrons in all atoms, and these atoms will always tend to arrange themselves in such a manner that to minimize the electron pair repulsion. So ये minimize करते हैं repulsion को, और minimize करने के लिए इनको जितना भी अपने आप के को change करना पड़ता है, they will change, and ultimately they will get the required shape. और different geometries जो हैं in this lecture, I will give you some different geometries which arises due to this valence electrons repulsion. Now, if we come over to the next slide, you can see the different things. So, valence shell electron pair. This is the structure which is planar, triangular. Okay. This is the structure. What is the basics of this planar triangular? Central atom with 3 attachments. Okay. Now we come to tetrahedral. So what is the base of the tetrahedral? Center atom with 4 attachments. Then we come to here, trigonal pyramidal. Trigonal pyramidal mein you can see that the center and 4 attachments. Now 1 attachment is replaced by this lone pair. So when one of the attachment is replaced by the lone pair, then what would be the impact? We will study with the help of valence shell electron pair. Now again we come over here, you see that there are total 3 attachments to the center. 2 are these, okay, and 1 is the lone pair. So again, there are three attachments. Basically, there are three, and due to this attachment, two lone pairs यहाँ पर हैं, आपको एक नजर आ रहा है, two lone pairs actually हैं. तो structure जो है वो जो है it will be bent structure. Next, let's have the molecular shape. Molecular shape. So VSEPR theory assumes that the shape of the molecule is determined by the repulsion of electron pairs. अच्छा, अब आप ये देखें कि फॉर एग्जाम्पल ये जो डायग्राम है, लुक एट दिस डायग्राम, दिस इज वेरी इंपॉर्टेंट डायग्राम. नाउ यू विल सी दैट दिस इज द negative and these are the positive, right? So negative and positive, they are going to be attractive. ठीक है, again these are the attractive forces. So ये सारी आपकी जो ब्लू में शो की गई हैं, these are the attractive forces. पिंक की जो forces हैं, these are the repulsion forces. अब आप ये देखें कि ये हाइड्रोजन है, this is hydrogen, these are the two electrons, okay, which one is contributed by oxygen and yellow one is contributed by hydrogen. So actually there are two electrons and it is shown as one. Again come over here and these are the two lone pairs. So actually ये आपको structure जो show किया जा रहा है, this is the structure of water, ठीक है, and due to the repulsion because of these two lone pairs there is repulsion, and due to that these hydrogens come a little bit closer to one another and angle reduced to 104.5. Now the important point is this, that check out that how many actual attachments are there with this center. So there are four, 1, 2, 3, 4. So just I told you that if four attachments are there, the shape would be tetrahedral. So then why there are four attachments, but the shape is bent shape and the angle is also different. This is only due to the impact of these two bulky lone pairs. Okay. Next, I move to the next slide. That is the VSEPR theory. It is based on electron dot Lewis structures. तो आपको full grip होनी चाहिए structures पे और वो भी electron dot. Theory predicts shapes of compounds and it is abbreviated like this, VSEPR, which is pronounced as valence shell electron pair repulsion. So actually this technique predicts shapes which are based on electron pairs. Repelling, इनकी repelling पे है, क्योंकि अगर ये repel करेंगे, दूर होंगे, डिस्टेंस रिपेल करेंगे तो डिस्टेंस इंक्रीज होगा, डिस्टेंस इंक्रीज होगा तो जो नीचे अटैचमेंट्स हैं बॉन्डिंग इलेक्ट्रॉन्स की, वो उनके ऊपर इसका असर होगा, वो थोड़ा सा अपनी प्लेस से मूव करेंगे. सो दैट्स व्हाई electrons around central nucleus repel each other, so structures have atoms maximally spread out. तो ये spread out maximally जितना भी कर सकते हैं ये spread करते हैं due to the repelling of the valence electrons. In this way, a definite and a specific shape is observed for a specific molecule. Now we come to the these things. So there मैं आपको सिर्फ first 5 जो shapes हैं इनकी I'm going to discuss in this lecture, and these are all the shapes. ठीक है, इसमें आप देखें कि first shape is tetrahedral. Tetrahedral की जो sequence है, it is this: center with 4 attachments and the angle 109.5 degrees. Then we come to second shape, which is called trigonal pyramidal, right? अब ये जो 3 shapes हैं, these 3 shapes, these are interconnected with one another. So the point is that you should know that how these 3 shapes are interconnected, and this could be asked in the MCQs also. Now tetrahedral has center carbon with 4 attachments. ठीक है, angle is 109, and this is the best representation in which the repelling is at maximum, and the shape is this, and the angles are finalized at 109.5. Now look at the next question, which is next structure. This is the structure of ammonia. So ammonia has 3 hydrogens and 1 lone pair. ठीक है, इट्स फिफ्थ ग्रुप में है ये. सो जब आप इलेक्ट्रॉन्स की डिस्ट्रीब्यूशन करते हैं एज पर द हंट्स रूल, लुइस लिखते हैं 1. Let me get the big one so that you can differentiate between the electrons. This is 1, 2, 3, 4 and 1 electron is left, so this is the pair, right? So the आपके पास 5 electrons हैं with one lone pair and 3 unpaired. Now these 3 unpaired, they are satisfied by hydrogens. ठीक है, ये hydrogens आपकी 3 इसके साथ react कर लेंगी. अब जो hydrogens हैं, they all bring their one alone electron, right? इनका अपना एक electron है. Let me have this 1, 1 and 1. ये इनका अपना एक electron है, right? So this is the mole. Now we are not interested over here. This is the Lewis structure of ammonia. So you should have a strong grip on the Lewis structures. Now the point here is that we are not interested in the Lewis structure, but we use this Lewis structure to predict the shape. That's the main objective. So आप ये lone pair जो है, it's a little bit bulky thing. ठीक है, तो ये repelling जब करेगा तो जरा से ये 3 hydrogens हैं, they come close to one another and angle decreases from 109.5 to 107.5. Now what is the important point over here? The important point over here is that actually nitrogen has 4 attachments, right? So actual shape इसकी tetrahedral होनी चाहिए थी. The shape should be tetrahedral as per the center with 4 attachments. But due to the presence of this bulky group, this is the attachment. अब जो attachment है आपकी वो 4 ही हैं, लेकिन lone pair repulsion जो है उसकी वजह से angle decrease हुआ तो shape भी change हुई and the shape has become now trigonal pyramidal. So I can say that this trigonal pyramidal is the distorted shape of the tetrahedral. Original कौन सी है? Tetrahedral. क्यों? 4 attachments. लेकिन due to the repulsion, जो distorted shape, it's trigonal pyramidal. So this is the shape for the ammonia. Next we come to the water, and you know that water, these are the 2 electrons. One is contributed by oxygen. ठीक है, one is contributed by oxygen and the other one is contributed by hydrogen, right? तो ये आ गया हाइड्रोजन का. ठीक है, this is the hydrogen and this is for the nitrogen. ये आ गए यहाँ, right? 2 electrons. Again, now there are 2 lone pairs. Now let me show you that actually the shape like this, 1 and the other is 2. So these both of them keep themselves away from one another. In doing so, a little exertion is imposed on these 2 hydrogens and the angle is further reduced to 105.7. So angle कितना आ जाएगा? 104 आ जाएगा तकरीबन, right? Yeah, angle. Now again, how many total attachments are there? 4. तो original shape क्या है? Tetrahedral. And distorted shape क्या है इसकी? Bent. And what is the reason for this reduce in angle and the distorted shape? That is the presence of these 2 lone pairs. Now we come to the structure. ठीक है, और ये आपका structure जो है ये वाला जो structure है 180 degree, this is the structure which is known as linear. और ये वाला जो structure है आपका, this is known as trigonal, planar. So यहाँ पे 180 degrees है and here is the angle 120. जो इसकी attachments 2 हैं, जब 2 attachments हैं तो linear structure हैं, जब 3 attachments हैं तो trigonal, well defined structure. But here is the exception. ठीक है, so what is the outcome? The outcome is this, that the shapes are totally dependent on the lone pair repulsions. Okay, next we move to the next slide, that is different models for tetrahedral, triangular planar, bent or V, trigonal pyramidal, and the linear structure. So these are the 3D structures for the different models. Now we move to the next slide. This is the structure of methane. So methane mein how many attachments are there? 4. What is the predicted shape? Tetrahedral. What is the predicted angle for tetrahedral? 109.5. तो ये अच्छा, अब मैंने आपको बताया था कि यूजली हम ये 2D स्ट्रक्चर जो है we write like this, but as per the VSEPR, valence shell electron pair repulsion, these hydrogens they arrange themselves like this. So ये एक tetrahedral structure बनता है, right? Ammonia. Now compare the things with ammonia. This is the comparative analysis of two structures. यहाँ angle, here the angle is 109, okay? Here the angle is 109 and here the angle is 105, 107, right? Now you can see the area which is covered by the hydrogen and the area which is covered by the full, lone pair. So that's why the angle decreases in ammonia and here the angle is 109. So ammonia ka jo structure hai, that is known as trigonal pyramidal, less repulsion between the bonding pairs of electrons. Yahan par, so that's why the angle is 109 and here the angle is 107. Now you can compare all these three. Now I think you understood completely that what is the reason. एक हमने मैथन का स्ट्रक्चर देखा, अमोनिया. Now this is for water. So look at the space which is occupied by these two lone pairs. So that's why original angle क्या है? 109. Why the original angle is 109.5? Due to the 4 attachments and the tetrahedral original structure. So distorted structure क्या है? 10. This is the bent structure is the distorted structure. And what is the angle? Angle is 104.5. What's the reason? The reason is this repulsion, right? Next we come to next slide. That is, you can see again different shapes. This is for tetrahedral, this is for ammonia, and this is for ये आपको इसमें नजर नहीं आ रहे. Let me show you. ये आपको एंगल्स नजर आ रहे हैं सारे. इसको एनिमेशन मैंने नहीं इसको किया. So these are the angles. Now we come to the next slide. Now you can see something like this. ये देखिए. These are the different shapes. ये इनके electrons हैं. These are the electrons over here, right? Next we go to the next slide. Next slide में आप देखें. It is showing the hydrogens कौन कौन सी हैं. ये जो अच्छा, अब आप इसमें आपके लिए दो चीजें आई हैं. एक आपके पास हैश आई है, right? Hash. This is when the bonds are shown like this, hash, or when the bonds are shown like wedges. These are the two ways. Whenever these two ways are used to describe the structure, quickly आप understand कर लेंगे the 3D structure has been shown. ये 2D structure है, लेकिन ये अमोनिया का और मैथन का 3D structure है. Hash का मतलब होता है कि the hydrogens which are not any attachment which is not within the plane and it's at the back side. तो बैक साइड पे ये चीज मौजूद है, बट हम उसको हैश से शो करें. हैश मींस कि दिस इज नॉट विद इन द प्लेन, दिस इज यू कैन नॉट सी इट, बट सिंस वी आर ट्राइंग टू राइट 3D स्ट्रक्चर, सो हमने उसको ये हैश में लिखा है, जो कि इसलिए हम लिखते हैं ताकि हम शो कर सकें कि हमारा 3D स्ट्रक्चर है. इसके अलावा इसे कहते हैं वेज. वेज का मतलब होता है कि ये आपका विद इन द प्लेन है. तो ये द होल स्ट्रक्चर इज द 3D representation of ammonia. Here there is no hash and there is no wedge, it means that this is the 2D structure. These two. Okay. Next, we go move forward. Now here, from this is the structure formaldehyde. This is the Lewis structure of formaldehyde. So when I go for the animation, so animation will be in the next slide. This is the structure of formaldehyde. Now you can see this is the first one is the Lewis structure and second one is the Lewis structure again. This is the Lewis dot structure and this is the normal Lewis structure. Now these are the shapes, VSEPR shapes, tetrahedral. Whenever the tetrahedral is there, आपको पता है कि sp3 hybridization है. When there is planar structure, always think that sp2 structure and there must be one double bond. When there is a linear structure, foreign immediately आप understand कर लें कि triple bond है और sp hybridization है. So this is all about the introduction to VSEPR. I hope